Okay, welcome back. Now I'm here with a small device which is doing quite a lot of work for us in the electrical engineering when we are running electric motors, like this one we've been talking about. This small device or component is called a relay. A relay is basically an electromagnetic switch. It is made up of a coil inside, and it has got what we call main contacts that are opened, and it has got some auxiliary contacts that can either be open or normally closed. So what happens as far as operation is concerned is when you supply power or voltage to the coil, which is inside, you connect maybe your live and neutral on those 2 points, the coil gets magnetized. And when it's magnetized, it will pull the set of normally open main contacts and close them. So what is happening is I'm just putting a supply here, live and neutral. The coil gets energized and it closes the main contacts. And if I've got power coming in and going out through there, then it means the power can go wherever I'm directing it to. In other words, I'll connect my L1 and L2, L3 on those 3 points here, red, yellow, blue, or live 1, live 2, live 3. And on the other side, I'll connect again other three other wires going to the machine, for instance, this. So what is going to happen is if I connect my supply to the coil, the three main contacts will close and the power will be able to pass through the contactor. Because right at the moment, if I've got power coming in and 3 wires going out, power will not be able to go out because at the moment the contacts are open. The contacts are open inside. But the moment you energize the coil, the contacts inside close, and when they've closed, power will be able to pass through. And it can pass through to wherever you want, either to the motor or in most cases it will have to go first to what we call an overload relay. This is an overload relay. This is an overload relay used to protect the motor against overloads. Right, but let's talk about the contactor first. Right, so first and foremost, when you're using a contactor, you have to establish the voltage required for the coil to be energized. There are various voltages contactors that are made with different voltages that you can use. Some can be energized by 110 volts, others 220, others 315 or 415 volts. So if you make a mistake of connecting the coil to 415 when it is 110 volts rated, then it will burn and you will lose out. If you do it the other way, if you, for instance, connect 110 when it is a 220 coil, basically nothing happens because the magnetic field is not strong enough to close the contacts inside. So you have to make sure that you connect the correct value of voltage for the coil. This in particular is a 250 volts contactor, which means the coil requires 250 volts. Just a live and neutral there, normal live and neutral, the coil will get energized. So once the coil is energized, then it means the contacts, like I said, they will close inside and the power will be able to pass through if you have got wires connected. So this is, in simple terms, an electromagnetic switch. It is a switch. We are using a very low voltage to close contacts where probably we have got a very high voltage. Remember what happens every time you are switching on and off a circuit. A spark takes place across the contacts of the switch, thereby burning the contacts of the switch. And again, it is really a hazard for somebody to be switching on and off manually very high voltages. And like I said, these machines, some of them are operating at a very, very high voltage. And if you were going to use an ordinary switch which you switch on and off manually, there will be many risks involved, because every time you're switching on and off, those sparks are taking place. An ordinary switch in your house, when you're switching on and off the lights, a spark also takes place across the contacts of the switch. Fortunately, you can't see the spark because the switch is closed, but the spark is happening inside. That's why after some time you find that your switch is no longer operating properly, and they have to replace it and put a new one. So now here we are talking of 415 volts or more, and we want to switch that 450 volts on and off, which means there's a bigger spark which takes place when you're switching on and off. But fortunately with this technology, you would not be doing that manually. You are using a high voltage to switch a very high voltage. You are using a lower voltage to switch a very high voltage. Okay, so all machines, all electrical machines, electrical motors, they apply the contactors, use of contactors for switching them on and off. Of course, there are other components involved, like your push stop start buttons, and so on and so forth. So depending again on the control, how it was designed, you see in most cases the control circuit is made up of numerous components and protection devices like control fuses. You also sometimes have main fuses to protect the motor windings against short circuits. But of importance is this other small component here, which we call an overload. An overload relay is for protection of against overloads on the motor. It has got some heater windings inside. So when there's an overload, obviously a higher current is going to be drawn from the supply, and as that high current passes through the overload units, they start heating up. And inside there's something like a bimetallic strip. So when they start heating up, they expand, and through the control circuit, they'll open the supply to the contactor, and the contactor gets de-energized. Once the contactor is de-energized, it releases the contacts that have initially closed. So there's an open circuit and no more current flows to the motor. So this happens automatically. You don't have to be there. The protection is done on its own. So the machine can be left running on its own 24 hours or 48 hours. As soon as there's an overload, the overload unit will react and send a signal to the control circuit so that the contactor will get de-energized and stop the motor. The motor would not run until somebody comes and resets the overload. There's a resetting button on the overload here. We don't encourage people to just reset. First of all, qualified people who want to know what has caused the trip, what causes the motor to stop. So first of all, they'll look for the cause for the overload, and then once they've rectified it, they can just reset the overload unit and they start the machine again. So basically that's how these two components work in a system, but I'll come back to you again with the full control system of the motor, and we shall discuss in more detail how we can design what we call a direct online starter for starting various machines. Suppose you want to run a pump at your house or at a farm or a grinding mill. You basically need what we call a direct online starter. That is starting the motor and stopping it safely. Okay, that's when we will be looking at this direct online starter. There are various types of starters that are used in electrical engineering, like the elder starter is very popular and very common and is being used in bigger machines. Okay, maybe one would want to know why different types of motors. We'll discuss about that as soon as I come back with another presentation to you. Thank you very much for your patience. I hope you have benefited something from me. Once again, I'm Stanley Kateguru. I am a Zimbabwean and I'm working here in Oman. Thank you.